In this video, we're going to look at sine law. We've already seen a few examples of sine law in the presentation. So in this particular video, I'm going to talk explicitly about the ambiguous case of sine law. Recall that we can write sine law in two different ways. Sine A, sine of the angle A over the side A, equals sine of the angle B over the side B, equals the sine of the angle C over the side C. I have referred to it as the jelly bean, whether we have a jelly bean or not, and that is because we can use sine law if you have a complete jelly bean. So for instance, if you have big A and little a, there's my jelly bean, and you have something else, let's say B, big B, then you can find little b. Or perhaps you have little c and you need to find angle C. So you can see I have the different jelly beans. If you have a complete jelly bean, the A jelly bean, or the B jelly bean, or the C jelly bean, then you are likely going to be able to use sine law. Before we consider the ambiguous case of the sine law, let's talk about two little things that we've learned before. First of all, we know that the angles in a triangle add up to 180 degrees. So if we know two of them, we can find the third angle. The second aside that I'd like to speak about, we learned in the unit circle, as we found all the points around the circle and the related angles, we learned that cos is always positive here. All the ratios are positive here, so sine, cosine, and tangent. Sine is positive here, and tan is positive here in the third quadrant. How does this have any significance to do with the ambiguous case of sine law? Well, we know that sine is positive in the first quadrant and the second quadrant. So sine is positive in two cases before it gets to 180 degrees. So if we have sine of some angle equal to a number, then that sine value could be in the first quadrant or in the second quadrant. So we need to look at both cases. You may be asking, why do I have this donkey up here in the top right corner? And I'm going to point out to you that it's about the case of sine law, where you have side-side angle. What does that mean? Here's a side, and here's an angle. Without the angle in between here, you do not have this angle or this angle. You have a side, and then an angle. This is the case, the ambiguous case, where you're going to have to consider possible options. I'm going to go ahead and solve this as if I don't have any understanding whatsoever of the ambiguous case. I can see that I have big A and I have little a, so I have one complete jelly bean. I also have little b over here, so if I have little b over here, that means I can find angle B. So I'm going to set the sine law up as if I were finding angle B. I always write the formula before I put in any of the values, and then I know exactly where to put my values. So I'm looking for the angle B, because that's the only thing I can find right now. I have both my A's, nothing about C, but I have my little b. So I'm going to find angle B. I plug this into my calculator and I end up with sine B equals 0.9405. So far so good. Let's use the inverse sine. I used my sine inverse and I made sure that my calculator was in degrees, and I end up with that the angle is 70 degrees. So this looks just like everything else that we've done. But remember, in the aside, we know that the sine of a particular angle could be positive in the first quadrant and second quadrant, so twice before 180. So we need to check the other angle related to 70 degrees. So that would be 180 minus 70. Okay, so I need to check for the second angle of 110 degrees. So my first particular angle, B1, could be 70, and my second one could be 110. So how do I know if that triangle exists or not? Well, let's check our triangle. In the first case, if B equals 70 and A equals 36, then we have enough left of the 180 in a triangle to make the 180. So 106, so 74 would be angle C. So that would be triangle 1. In triangle 2, our B could be 110. We know the A is 36, and we just have to ask ourselves if there's enough left over to make a full triangle. So 110 plus 36 is 146, and 180 minus 146 rather, is 34. So yes, a second triangle is possible. So in this particular case, we know that two triangles are possible. So a review from the top, we see that we have the SSA applied here, which is the ambiguous case. We need to check to see if there are two triangles. The first one would be like what you see here, and the second one means that maybe you would have a side coming down here instead. So we might have two possible triangles. As I work through the question, I pretend like I don't know that, and I get my first triangle with an angle of 70 at B. So this would be 36, 70, and then the last one would be 74. So that's definitely a triangle. I remembered from the cast rule that sine could be positive twice between 0 and 180. So I check for the second angle. I take 180 minus 70, which was the first one I found, and I get 110. So my second possible angle for B is 110. So that would be over here if the triangle was like this. So then I try the 110 with the 36 that already exists for A, leaving me 34 for the top. So yes, that is also a possible triangle. So in this case, there are two possible triangles. Okay, so once again, we have a little donkey up here, so we're trying another question like this. So here's the side, and then right beside it, another side, and then we have an angle. So at this point in time, we need to think about whether we have one triangle possible, two triangles possible, or no possible triangles. Like before, I'm going to do the jelly bean. So I have an A jelly bean, so angle 73, and then the side 35. And then the second jelly bean that I'm going to be figuring out is the B. So I'm going to set that up. So once I plug in the numbers and I rearrange, I end up with sine B equals 1.2842. Perhaps one of the other things we learned about the unit circle is that no matter how many times you go around the circle, no matter how big the angle, and with triangles it only matters to 180, the sine of any particular angle is less than 1. So this value is greater than 1. So that means that we're not going to be able to do it. And in fact, if you put this into your calculator using your sine -1, in Desmos, I got undefined. So this triangle is not possible. So what does that mean in terms of this actual triangle here? It means that this particular side is not long enough to reach the side here. If you have a side of 47 here and an angle of 73 here, the 35 is not long enough to reach this side. So it falls short. There is no triangle possible here. So therefore, there is no possible triangle. How did we do that? We set it up like usual, checked for the jelly beans, realized that I could solve for B. I set up my sine law to solve for angle B. I put it into the calculator and I end up getting 1.2842. I try to use sine inverse, but I get undefined. This value is greater than 1, and we know that the sine of any angle as you go around the circle is always going to be between -1 and 1. So this is not possible. If this is not possible, then there is no possible triangle. And that is the other situation with the ambiguous case of sine law. Good luck.